Good evening, my dear students. This is functions part 2 video. In this part, we discuss some points. First one, modulus function. Second, real functions. In that, real variable function, real valued function, real function that we discuss here. Third one, identity function. Fourth, composite function. Fifth one, equality of functions. Sixth one, even and odd functions. Now we discuss that. These points. First one, that is modulus. If the function is defined as f of x equal to mod x, actually mod x is defined as like this. That is always greater than or equal to 0. X if x greater than or equal to 0 and minus x if x less than 0. That is modulus x. For example, modulus of 7 equal to 7. Modulus of minus 4, look here. Here 7 is positive. That's why mod x taken as x only. Minus 4 is a negative number. In case of negative number, x negative, mod x is defined as minus x. That means minus of minus 4, that become 4. So, mod x is always positive quantity. Mod 0, 0. Mod 0 is 0. Equal to 0. So, mod x is always greater than or equal to 0. As well as mod x is equal to maximum of minus x comma x, that is modulus of x is maximum of minus x. So in these two numbers, which one is maximum? That is mod x. Okay, now the graph of this function is like this, mod x v shape at 0, that is mod x graph. Now we discuss the next point, that is real function. Real function. There are three subpoints. That is f mapping from a to b a function. F mapping from a to b a function. 1. If a is subset of b, then f is called real variable function. Real variable function. Next, second one. If b is subset of R, in the above, a is subset of R. Second one, if b is subset of R, then f is real valued function. Real valued function. Third one, that is, if a subset of R and b subset of R, then f is called real function. Real function. This is second point, that is real function concept. Now identity function. Third one, if f mapping from a to a, then f mapping from a to a is defined as f of a equal to a for every a belongs to a. F is a function defined on the set A such that f mapping from a to a, f of a equal to a for all a belongs to a, then that is called identity function, that is denoted by I. I is identity function defined on a, sometimes that is denoted by IA. IA is an identity function a to a. IB is an identity function b to b. This is an identity function. For example, if you take a equal to a, b, c, the function is defined as, identity function is defined as a, b, c. A mapping to a, b mapping to b, c mapping to c. That function is called identity function. That is called identity function. F of a equal to a, f of b equal to b, f of c equal to c. That is identity function. Now we are going to the fourth point, that is composite function. F is a function from A to B and G is a function from B to C. F is a function from A to B and G is a function from B to C. The connection of these two functions is A to B, B to C. F codomain is equal to the domain of G, then the composition is exists A to C. G circle F, that is composition of F and G mapping from A to C. Once again, A to B is a function F, B to C is a function G, G circle F, reverse, G circle F mapping from A to C. It is called the composite function of A and B. G circle F is defined, G circle F is defined if G domain equal to F codomain, G domain equal to F codomain. Domain means this is domain, this is codomain. Domain, codomain. If G domain equal to F codomain, then G circle F is defined. If G circle F is defined, F circle G need not be defined. If F circle G and G circle F both are defined, then these two need not be equal. F circle G not equal to G circle F. Okay. Now, this is called the composite function. For example, if you take f of x equal to 2x plus 3, g of x equal to x square. Now find g circle f and f circle g. G circle f of x, for example, first one, g circle f of x, that equal to g of f of x. F of x is x square, g of x square. F of x is defined as 2x plus 3. 2x plus 3. G of x is defined as x square. G of x is x square. So g of 2x plus 3 equal to 2x plus 3 whole square. Now, f circle g second. F circle g of x, that is equal to f of g of x. G of x is defined as x square. So f of x square. F of x square, f of x is 2x plus 3. So f of x square is, just we have to write down x square in place of x in f of x. So here f of x square equal to 2x square plus 3. Look here. The first one is g circle f of x. It is g circle f of x. It is f circle g of x. Clearly, g circle f of x not equal to f circle g of x. These two are not equal. These two are different functions. This is called the composite functions. G circle f, f circle g, composition of the functions. Next. The properties of the composition functions, that is f circle g not equal to g circle f. The composition is not commutative. Composition is not commutative, but composition is associative. That means f mapping from A to B, g mapping from B to C, and h mapping from C to D, then h mapping from C to D, h mapping from h circle g circle f equal to h circle g circle f. This is called associative property. The composition of the functions is called associative, satisfy associative property. H circle g circle f equal to h circle g circle f. We can take this bracket for these two or this one. Next one. If f mapping from A to B, look here, A to B, the connection f, g, h, h circle g, G circle F. H circle G is B to D. G circle F is H circle G mapping from B to D. G circle F, H circle G, that is G circle F, mapping from A to C. Composition function, that is. Next point, F mapping from another property. F mapping from A to B and IA mapping from A to A. IB mapping from B to B. Then the relation between them, that is A to B, A to A, A to B, B to B. It is F, it is IB, it is IA. Now, F circle IA, IB circle F. F circle IA equal to F and IB circle F equal to F. F circle IA mapping from A to B. F circle IA, actually F circle IA mapping from A to B. Once again, F circle IA mapping from A to B. F circle IA mapping from A to B. Next, IB circle F mapping from A to B. F also mapping from A to B. So, F circle IA equal to IB circle F equal to F. It is called the identity property. Composition of any function with identity is itself only. F circle IA equal to IB circle F equal to F. Now we are going to the next point, that is equality of functions. Equality of functions, it's very important. That concept is used in very standard formulas, very important formulas in board exams. Equality of functions, that is the fifth point. F mapping from A to B and G mapping from C to D. F and G are said to be equal if they satisfy the conditions. First one, F domain equal to G domain. Second, that means that is A equal to C. F codomain equal to G codomain, that is B equal to D. These two domains are equal and codomains are equal. Two conditions. Third condition is F of x equal to G of x for every x belongs to A. First, F and G defined on the same domain to same codomain. That is the first condition, first and second conditions. Next one, the function values are same. Function values. F of x equal to G of x for all x belongs to A. This is called functional values are same. If these two functions satisfy these conditions, then we say that F equal to G. F and G functions are equal. That only happened. Next, now we are going to the very important and interesting topic, that is even and odd functions concept. Now we discuss that. That is the last point. If f of minus x equal to f of x, then f of x is said to be even function. F of minus x equal to f of x, then f of x is said to be even function. For example, f of x equal to cos x, this is an even function. How you say that that is even function? F of x is cos x is even function. That is f of minus x equal to f of x. You check that f of minus x, just we have to write down minus x in place of x. That is cos of minus x. That is cos x. Cos of minus theta is cos theta. That we learn in trigonometry. That is equal to f of x. By definition, f of minus x equal to f of x. In that case, f of x is said to be even function. So cos x is an even function. Next point, if f of minus x equal to minus f of x, then f of x is said to be odd function. For this example, f of x equal to sin x is an even odd function. How you show that it is an odd function? F of minus x, just we have to write down minus x in place of x, that is sin of minus x, that is minus sin x, that is equal to minus f of x. So, my dear students, f of minus x equal to minus f of x. By definition, according to the given definition, f of x is odd function. So, sin x is an odd function. Here, one important point, that is every even function is symmetric to x-axis. Every odd function is skew symmetric to y-axis. Here, cos x, you know, the graph of cos x, that graph is like this. This graph is. You see this? Observe this graph. The graph, you observe that it is y-axis, it is x-axis. Clearly, left side of y-axis is same as the right side of y-axis. It is the graph of y equal to cos x. So, every even function is symmetric to y-axis. Symmetric. Left side part is same as the right side part of y-axis. Now, every odd function is skew symmetric to y-axis. This one, skew symmetric to y-axis. Now you observe the sin x graph, that is sin x graph like this. Sin x. It is skew symmetric to y-axis. Skew symmetric means left side of y-axis is reverse of right side. Left side of y-axis is down, the same part right side up. So this is called skew symmetric to y-axis. Every odd function is skew symmetric to y-axis. Now we discuss the relations, the properties of even and odd functions. Now we discuss that points. The sum of two even functions is an even function. The sum of two even odd functions is odd function. Now we discuss the properties of even and odd functions. That we discuss that. F of x and g of x are even functions. Then f of x plus g of x, f plus g is even, f plus g even, f minus g is also even. The sum and difference of two even functions is again an even function. Next one, the product of two even functions is again even function. The division of two even functions is again even function. It is f of x plus or minus g of x, f of x into g of x, f of x by g of x. These are all even functions. If f of x and g of x are odd functions, what about that? Are odd functions, then first one, f plus or minus g is also odd function. Second one, f into g is not odd function, it is even function. The product of two odd functions is even function. The quotient of two odd functions is even function. Odd function, odd number, these two are different. Even function, even number, different. Number is different, function is different. So, even or odd functions, according to the definitions, based on the definitions, we decide that is even or odd functions. But here, don't confuse even function for even number. So these are the properties of even and odd functions. So my dear students, these are important for competitive exams as well as the board exams. Keep in your mind these points. Thank you very much. Bye.